Hello boys, and welcome to this online lesson. Hopefully you can see me or at least hear me pretty well here. Today we're going to be doing some problem solving again, and we're going to be looking at algebra this time. So in the last lesson last week I did problem solving with a geometry focus. This time we're going to be looking at some algebra. Now I've already had a message that it was difficult to see the questions at the start, and I think the issue there is that if there's quite a lot of people in the stream, sometimes it makes my image quite small, so hopefully we won't run into too many problems. If that is the case, and that you weren't able to properly see everything, don't worry, because the lesson is being recorded, so I'm recording everything right now, and when that is eventually uploaded, I'll probably put it on YouTube. It will be full screen, so you'll be able to properly see everything. And I've also got a dual camera setup this week, so that will also, added production value and all that. Today, though, what we're going to be looking at is we're going to be doing some problem solving, as I said, and let's start off by looking at those 5-a-day questions to start with. Now, a key theme for a lot of the things that we're going to be doing today is, let's just move that. Yeah, key theme is going to be that we are looking at the strategy for solving problems, okay? So not just looking at the problems themselves and how to come up with an answer, but the strategy behind getting the answer, okay? So let's have a look at these questions here. Now this first one, the trains to Portadown and trains to Portrush, this is a very typical sort of question that comes up in the GCSE papers, and it is the sort of question where there's two trains happen to leave at the same time, they take different amount of times to get there, and then you've got to work out the next time that they arrive together. That's a very common type of question that can come up. And the strategy here, we should be finding the lowest common multiple of 32 and 28. Okay, so we're looking for the LCM, the lowest common multiple of 32 and 28. And there's lots of different strategies to do that. The way that I quite like is that if we write down 32 and 28, we can find the prime factor decomposition. So that's when we do that tree thing. And so we'd get 2 times 2 times 2 times 2 times 2. Oh, you can only see half of the question. Okay, so let me see if I can do anything. I don't know if there's anything I can do about that. I'll see. Is that any better at all if I zoom out a little bit? That should be in the middle of the screen. Yeah, that's better. Okay, good. So we should have 32 and 28. We're trying to find the lowest common multiple there. And so I've done the prime factors. So 32 is 2 times 2 times 2 times 2 times 2. So 2, 4, 8, 16, 32. And then 28, that is going to be 2 times 2 times 7. And then the lowest common multiple here, well, we need to include every single one of these. So we need 1, 2, 3, 4, 5 2s. And then we also need a 7 as well, because these 2s will already be counted from some of the 2s from the 32. So that's 2 times 2 times 2 times 2 times 2 times 7, which, according to my calculations, is 224. That means in 224 minutes, they will both be in sync again. So they will both arrive at the same time, or they both leave the train station at the same time in 224 minutes. Well, that is the same as 3 hours and 44 minutes. And so from 8 a.m, we need to add on 3 hours and 44 minutes. So that is 11:44. Okay, so that's how to do the first question. The next one, the spinner is spun 3 times, and we need to find the probability that the spinner lands on red at least twice. So the way I'm going to do that is we need to think about that as either landing on red or not landing on red. Okay, so we've got the spinner is being spun 3 times, so we could either have it doesn't land on red, so I'm going to put red with a line over the top, or it does land on red and then it does land on red. It could be it lands on red, then it doesn't land on red, and then it does land on red. Or it could be red, red, not red. Or, of course, we could have 3 lots of red, 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 red. Okay, these are all of the possible options. And I've put multipliers here because we're going to be multiplying the probabilities together. So, if it's not red, well, there's going to be 2 possibilities out of the 3, so that's 2/3. Multiplied by 1/3 multiplied by 1/3. Again, 2/3 times 1/3 times 1/3. We've got 2/3 times 1/3 times 1/3 again. And then 1/3 times 1/3 times 1/3. And if we multiply all of these together, this is 2/27 plus 2/27 plus 2/27 plus 1/27, and so altogether that is 7 out of 27. So our answer there is 7/27. Okay, moving on. We've got some more questions over here. David buys 2 DVDs and 2 CDs in a shop, and the total that they cost is £32. Ellie buys 3 DVDs and 2 CDs, and they cost £43. And we've got to find the value of each CD and each DVD. Now, this is a simultaneous equations question, so we can create 2 equations. We need to form 2 equations in order to solve this. So, first of all, we will have 2D plus 2C is equal to 32, and we've got 3D plus 2C is equal to 43, and now we need to work out what 1D is by subtracting one from the other. So 43 minus 32, that gives us 1D is equal to 11, and then if we substitute that 11 back into here, that means that we've got 22 plus 2C is equal to 32, and that means that C is equal to 5. Okay, because 2C would be equal to 10, so 1C is equal to 5. Okay, next one, simplify the square root of 63. Okay, so for this one, we need to remember our rules for dealing with surds. So if we've got the square root of 63, well, that's the same as the square root of 9 multiplied by 7. 9 multiplied by 7 is 63. And I've picked these numbers because I know that 9 is a square number. And so this is going to be the square root of 3 squared multiplied by the square root of 7, which is going to be 3 root 7. And then finally, another probability question here. We've got a bag contains 6 yellow sweets and 6 blue sweets. A sweet is taken out at random and it's replaced, it is put back in, and then another is taken out. What is the probability that at least one sweet is blue? Well, this is going to be quite easy. We could do it as a table this time. And so we're going to have either a yellow sweet picked first or a blue sweet picked first, and then again we've got a blue and a yellow. And so the options that actually let's undo that. That didn't make much sense, did it? We've got 4 options. Either we've got a blue then a yellow, a blue then a blue, a yellow then a blue, or a yellow then a yellow. They are the 4 options. And actually we've only got one case, we've got 3 cases where we pick at least one blue, and so we've got 3 out of 4 is the probability there. That's quite a simple one. Okay, let's move on. So what we're going to do, this is the first question that I'm going to put up here for you. I want you to try and work this out on your own. This shouldn't take too long. I'm only going to give you a couple of minutes. We want to use all of these digits, so 0, 1, 5, 0, 1, 5, 0, and we want to complete this multiplication. So we put 3 of the digits together to make a 3-digit number, multiply by 2, and then 4 of the digits to give a 4-digit number. Now, it's quite simple, but what we're looking at today is the strategy. So, see if you can do this. I'm going to give you a couple of minutes, and then we'll go through the answer. Okay, let's stop there and let's have a look at the answer to this. So, what we should see here, it shouldn't have taken too long, and I think there's a couple possible answers, but let's think about that strategy. So, we need to narrow down where the possible answers, where the numbers are going to fit. The first thing that I would think about is that we're going to be multiplying by 2. So let's think about those 1 digits. Now, if we put those 1 digits in this first box here, what's going to happen there is that when they multiply by 2, those 1s are going to turn into 2s. Wherever they are in that first box, if we double 1, we get 2. And we don't have any 2s to use up. So we can't have the case where 1 is in the first box. So we must have the 2 1s are going to go into the second box. Okay, they make up the second number, the 4-digit number. Okay, so that's good. We've narrowed down a little bit. We've got a strategy. We're starting to think about it a little bit more logically. The other numbers, the 5s, well, what happens if the 5 was one of the numbers here? Well, if 5 is in the second number, the 4-digit number, we need to think of a number that doubled in order to make 5. Well, that would have to be 2.5, and we don't have any 2's in the digits again, so we can't possibly have the 5's being in the second number. So the 2 5's must go in the first number as well. That should make it a little bit easier. If the 5's have to go in the first number and the 1's have to go in the second, it should be quite a lot easier to work it out. Let's just try. If we put a 5 in the last digit, well, if we double that last digit, we get from 5 to 10. So we'd have to put a 1 and a 0 here. So that means we've used up a 0, a 1 and a 5. And all we've got left is another 0, a 1, a 5 and a 0. Okay? So let's suppose that we put a 5 in the first one. Well, if that doubled, then we'd get 10. Oh, and that's fine. And we've got 505 and 1010. So that would work. The other scenario is that we actually have 550 multiplied by 2, and that equals 1100. Okay? So these are the two possible outcomes there. We've got 505 or 550, and they multiply by 2 to give 1010 or 1100. Okay. Pretty straightforward, that one, but that's what we're looking at, is the strategy and trying to make things simple so that we can, work things out a bit more logically. Let's have a look at the next one. So this question here, hopefully you can see it, we're going to be dealing with coins this time. So here we go, here's the question. So Janice has 3 coins in her pocket, and they are all different. Bearing in mind we're using the coins, the standard British coins, so 1, 2, 5, 10, 20, 50, £1 and £2. Okay, these are the numbers the coins that we're going to use. So Janice has 3 coins in her pocket, and they are all different from each other, and Jeremy has 3 coins in his pocket, and they are all the same as each other. And Jeremy is going to have twice as much money as Janice. What are the coins that they each have? And I can tell you now, there is only one possible solution that will work. So think about the strategy. Don't think about just trying to pick numbers and hope that it will work. Try and come up with an actual strategy to make your life easier. I'll give you 5 minutes to work this out, and then we'll go back again. Okay, let's have a look at the answer to this. So with this question, what we should be doing is we need to have a good strategy. Like I've been saying all along, a good strategy is what we need. Now, quite a lot of people, when I've done this question in the past, the tendency is, because the question is giving you Janice first, is to think about Janice, because that's just the way that the question is written. It's saying about Janice has 3 coins and they're all different, so let's start with Janice. Now that is not the best strategy to take. I think it's a lot easier to be thinking about Jeremy's coins, because he has 3 coins that are all the same. If we start with Janice, and we've got the coins 1, 2, 5, 10, 20, 50, and then £1 and £2. I've written 100 and 200 because it's going to make the maths a little bit easier, but £1 and £2. And we could pick any 3 of those coins. We've got a lot of possible options there. We could have 1, 2 and 20. We could have 5, 100 and 10. There's a lot of possible combinations there. And so if we try and think about Janice, it's going to be very difficult. We're not going to narrow down what we need. It's just going to leave everything quite open. So what we should do instead is think about Jeremy. That's going to make it a little bit easier because we know that his 3 coins are the same. That means that if the coins are 1, all 3 of them are 1. We have a lot fewer choices. We actually only have 8 possible choices. They're either all 1, all 2, all 5, or 10, 20, 50, £1, £2. They have to be all the same because that's what we're told. So once we know that, and we're thinking about Jeremy first, it's a little bit easier to narrow down what we need. Now let's start off. Let's suppose that they are all 1. Well, in that case, if all 3 of them were 1, that means his total amount of money is 3 pence. So if they were all 1, then Jeremy would have 3 pence, and Janice would have to have 1.5 pence, and there's no way of having 1.5 pence, so 1 doesn't work. If Jeremy's coins were all 2 pence, well, that means he would have 6 pence in total. That means Janice has to have 3 pence. Now, is there a way of getting 3 pence by using 3 different coins? No, there isn't. There's no possible way. You could have 1 and 2, and then you've already got 3. There's no other coin. You can't have a 0 coin. So 2 pence doesn't work. And now we can repeat this process. See, now we've got a strategy. We're going logically through each of the steps. We can just choose each of the coins. We can have a look at 5 pence. Does it work? Well, Jeremy's going to have 15. That means Janice is going to have 7.5. Well, that doesn't make sense. So that's not going to work. And we've already eliminated 1, 2, and 5. We've already managed to eliminate some of these choices, and we've now narrowed it down. There's only 5 more options that we can look at. So let's look at 10. If he has 10 pence, that means in total he's got 30 pence. That means that Janice has to have 15 pence. Is it possible to make 15 pence out of 3 coins? Well, let's have a look. If to make 15 pence, well, we could do 10 and 5, but then we need another coin, so that doesn't work. 10 and 2, well, that would be 12, but then we need another 3, that doesn't work. 10 and 1, we need another 4, that doesn't work. 20 is too high, so no, it isn't possible to do it. So 10 isn't going to work. Next, we can look at 20 pence. So I'm going to carry this over here. So 20 pence. Jeremy would have a total of 60 pence, and that means Janice would have 30 pence. Is it possible to make 30 pence out of 3 different coins? Again, it's not possible. You could have a look at the combinations if you want, but if we had a 20 and a 10, that's already 30. 20 and a 5, well, we're going to need another 5, that's not possible. 20 and 2, we're going to need another, however much, 8. And so that's not possible either. Let's have a look at 50. So if we started with 50 pence, that means that, anyway, let's put, Jeremy is going to have £1.50. That means Janice is going to have 75 pence. Is it possible to make 75 pence? Yes, it is. We could have the 50 pence, the 20 pence, and the 5 pence. 50 and 20 is 70, plus the 5 is 75. That works. And so actually, that is our final answer. We're going to have Janice has got a 5 pence, a 20 pence, and a 50 pence. Jeremy, they are all 50 pence, and that works. It's a good strategy, it's logical, we go through the steps, and we know we're definitely going to find the answer because we're eliminating things as we go. We know it couldn't be 1. Jeremy couldn't have 3 1-pences, he couldn't have 3 2-pences, and we keep on going until we get to the point where, yes, he could have 3 50-pences, and so that must be the answer. So what I'm getting at is that coming up with a good strategy in order to answer these questions is the key to solving these problems, these AO3 type problems, which I mentioned before. AO3 are these in-depth problem-solving questions that rely on lots of knowledge from lots of parts of the course. Okay, so it's going to be really important that we come up with some sort of strategy in order to solve these problems, rather than just trying to go in and hope for the best. Okay. Most of the time, 99% of the time, if you're just going in and trying to hope for the best and just doing it a bit trial and error, you can get to the right answer, but it's going to take you a lot longer than if you have a clear, logical strategy with clear steps to take. Okay, so that's what we've got to try and do. We've got to make sure that we've got a good strategy. Let's have a look at another question. So this is a really common type of question that comes up in the GCSE papers. So equal money. Luke has got £3.20, Lottie has got £4.50, and we've got to work out how much they would each have if they shared their money equally. And there's a slight variation on this question. It is how much does Lottie give to Luke so that they both have the same amount? So how much does Lottie give? Does Lottie give to Luke so they have the same amount? I'm going to give you 5 minutes to try and work this out, and then we will go through the answer. Try the first one to start with, just how much would they share equally, and then think about the second part there for how much would Lottie have to give to Luke so they have the same amount. I'll give you 5 minutes. Have a go at that now. And so what we would do then is we would have to find the difference between £4.50 and £3.85, which is 65 pence. Okay, so if Lottie gave Luke 65 pence, they would both have the same amount. Okay, common sort of question appears towards the middle or beginning of the paper. Quite simple, but when you don't have this line here, it gets quite difficult, because people, what they tend to do, what a lot of students do that I've seen, is if they're just told this is how much each of the people have, so £3.20 and £4.50, and then they are asked how much does Lottie give to Luke, what a very common thing to do is they half this amount, so that would be £2.25, and they give that to Luke. That is the incorrect thing to do. Obviously that would mean that Luke would have far too much money and they wouldn't have an equal amount. The correct way is to include that step here, so that you work out how much money should they have equally, and then work out how much they'd have to share. Okay, so that's the strategy that we'd take there. The way that it's written is actually the strategy that we would be wanting to take. Let's have a look at this one. So some algebra now. So expand. We want to find all the pairs of values for a and b if 2x plus a multiplied by x plus b is equivalent to 2x squared minus 18. Okay, there's a lot going on here. This is a tricky question, typical AO3 sort of question where they're not giving you much direction. You've got to try and work it out. I'm going to do the same. I'm not going to give you much direction yet. I'm going to let you try and work it out, and we'll come back in about 5 minutes time and see if we can come up with an answer. Okay, let's have a look at the answer to this then. So, again, theme of the day, strategy. We need to have a clear strategy, and we need to unpick what is actually being asked in the question. And so, what we've got is we want to find the pairs of values for a and b if 2x plus a plus multiplied by x plus b is equivalent to 2x squared minus 18. That word, equivalent, that's the one that we need to know what that is talking about. Okay, so equivalent is the key word in this case. We need to know what equivalent means. And here, what it means is equal to. If two things are equivalent, they are of equal value. So what we can do is we can rewrite this as, and let's zoom in a little bit, 2x plus a multiplied by x plus b is equal to 2x squared minus 18. Let's get rid of my webcam, that'll do. Okay, so 2x squared plus a, 2x plus a multiplied by x plus b is equal to 2x squared minus 18. Okay, that's the first step. The next step is multiplying or expanding that bracket. That's why it's called expand. Okay, so it's giving you a clue in the title for this question, but you wouldn't necessarily have that title if you were doing it in an actual paper. So what we need to do now is we need to expand the brackets. So to do that, use whichever method you like. I'm going to draw in some lines. So we're going to do 2x multiplied by x, so that's 2x squared. We're going to do 2x multiplied by b, so that's plus 2bx. A multiplied by x, so that's plus ax. And a multiplied by b, so that's plus ab. And that is equal to 2x squared minus 18. Okay, that's what we've got from expanding out those brackets. Next, what we need to do is we need to start to cancel things out. We need to collect together like terms, and we need to try and solve this equation. So to do that, what we need to do is we need to look at the 2x squareds. Okay, both sides of the equation have 2x squared there, and so what we can actually do is we can subtract 2x squared from both sides. In effect, that's like cancelling those 2x squares. That's just ignoring them. Okay, if you imagine it another way, if we had a big I don't know, p at on both sides, so we had plus p on both sides, that's not going to change the value of the equation at all. It's just adding on the same amount to both sides, and so we can get rid of that amount from both sides. We can get rid of the 2x squared from both sides. I'm going to write it out again. So we've got 2bx plus ax plus ab is equal to negative 18. Okay, we're getting there. We're making progress. We would have got a mark so far just by doing that. In fact, we probably would have got 2 marks. We'd get a mark from expanding out the brackets, and we would have got another mark from then cancelling that 2x squared. Okay, so we're doing all right. The next thing we need to do is we're going to compare coefficients. Now that sounds like quite a fancy mathematical thing, but what it means is we're going to look at the x's on one side and the x's on the other side, and those two things should be the same. Okay, the whole equation is equal. We've got an equation, an equal sign. That means whatever is on the left is equal to whatever's on the right, left and right, and so that means that everything on the right hand side, that minus 18, is equal to all of the numbers on the left hand side, and all of the x's on the right hand side, so over here there are 0 x's, is equal to the 2b plus a lots of x. Okay, so we've got 2b plus a. That means that, in fact, let's factorize this. We're going to have x lots of 2b plus a, or in fact let's do 2b plus a, x plus ab is equal to 0x minus 18. So that means that if we just compare the coefficients, we look at the coefficients of the x's on each, that means that 2b plus a is equal to 0. And it also means that ab, or in other words a multiplied by b, is equal to negative 18. So, in other words, what we're looking for is two numbers two values. We're looking for pairs of values for A and B. Two numbers that multiply together to give negative 18. And when we do A plus 2B, so one of the numbers plus double what the other number, that equals 0. They cancel each other out. So, at this point, let's write down some of the multiples, some of the two pairs of numbers that that multiply together to give negative 18. Okay, so I'm going to put negative 18 at the top here, like this. And the pairs of numbers, well, we could have 1 and negative 18, 1 times negative 18, or we could have negative 1 times 18. We could have 2 times negative 9, or negative 2 times 9. You see where this is going? We could have 3 times negative 6, or we could have negative 3 times 6, and that's it. Okay? There are others that would be decimals, but those are all of the integer, the whole number solutions, the pairs of numbers that would multiply to give 18. Now, of all of those, which of those are the ones where if we add one of the numbers plus double the other number, it would equal 0? Well, there's only two possible solutions there. That's these two here. If we double this number, okay, so I'm going to write that in red, so this would be 6 and negative 6. Now we can see when we add those together, 6 plus negative 6 is equal to 0. Negative 6 plus 6 is equal to 0. So the pairs of numbers, we have to make sure we get them the right way round. Which one's the one that's being doubled? The B is the one that's being doubled. So we can say that B is equal to 3 and A is equal to negative 6. Or we could say that B is equal to negative 3 and A is equal to 6. Those are the two pairs of solutions to this equation. Now, let's just take a pause and have a look at everything. I'm just going to summarise what we've got there. This is a tricky question, but there's plenty of parts that we can get marks here. This part here, expanding the bracket, that we said was worth a mark. That should always be your go-to thing. If you see a pair of brackets in an equation, chances are you're going to have to expand them. Okay? And even if you do that and it ends up that you didn't need to expand it, it doesn't matter because you've already done it. So, expanding the brackets is always the first step. Once we've done that, we're going to cancel things out. Okay? We cancelled out those 2x squareds. Okay? Once we did that, the next step, this is the tricky step, is the comparing coefficients. Okay? And comparing coefficients is quite a new thing. I don't think you would have done it before. But it's a fancy thing where we just look at the x's and we look at the numbers and we compare them on the left and right hand sides of the equal sign. And that allows us to see that, well, on the left hand side we had 2b plus a. That has to be equal to 0. And then once we've done that, we can start to solve the equation a little bit more easily. Okay, so hopefully that made sense. What I'm going to do is I'm going to wrap it up now because I think that it's a lovely, beautiful day. It's very warm. Let's turn that off. And so I think it's probably time to wrap up the lesson. I think we've probably done enough and we want to get outside in the sunshine. So hopefully you have enjoyed this. Hopefully you've got a lot out of it. The main takeaway that I want you to have from all of this is that having a strategy when attempting questions is going to make or break how you do in the questions, okay, how you do in the problems. It's really, really important that you approach the questions in a logical way so that when you're trying to find your answer, you don't just dive in and have no idea what to do. If you come up with a strategy and you know you have a clear step-by-step process, it's going to make your life a lot easier. Now, obviously, spotting the strategy is quite difficult, and hopefully if we do more of this practice, you'll get used to trying to find the strategy straight away. A lot of it is just about practice. The more and more we practice, the easier you are going to find it. Okay, so strategy is the goal of today's lesson. Hopefully you found it really useful. We will wrap up now, but thank you very much for joining me. If you've got any questions, please pop them down in the chat, and I'll stick around for another 5 minutes or so. But if you don't have any questions, you can leave now. So thank you very much, boys, for listening, and I will speak to you all next week. Hope you enjoyed it. Stay safe, boys.